Today, I will talk about failures, because failures are something that happens every time when we work on data, and especially when we work on data visualization. I want to talk about my failures and why I decided to use this title. This title because I think that in a context like a data sprint, it's very important to understand that sometimes you need to do stuff, you need to try, you need to create visualization to maybe realize that they didn't work. But why they didn't work? Why a visualization doesn't work? This is maybe related to the users. So who is looking at the visualization? How much is important the presence of the user, and who is that user? Elijah Mix is a senior information designer at Netflix. During the Tapestry conference a few months ago, said that we are approaching the third wave of data visualization. And the focus of this third wave of data visualization will be the expectation of the users, not the capability of tools, so the capability of tools, but the expectation of the users. So basically, we are approaching the exploratory design era, where the tools were, used by users, and the point will be the expectation of the users. But already in 2000, Guy Bonsiepe, a design theorist, said that basically a good information designer, the job of a good information designer is to reduce cognitive complexity and present knowledge, information to the user, to his audience. And in this theory called DKI theory, Guy Bonsiepe said that data, from raw data, becomes information and then knowledge. But data becomes information when someone gives a structure to data. Someone's like a computer scientist, for example. And information becomes knowledge when someone, like a designer, presents information. And in this journey from data to knowledge, there are many people involved, like a computer scientist or someone that gives structures to data, a designer that presents information. But what is really important is the user. Users are not all the same. We have domain experts, maybe in medicine, social sciences, law, or computer science itself. And the way the user internalize information, understand information, and interpret information build the knowledge. So here we have a kind of loop between user and designers, because when you're doing visualization, you are testing visualization. And so this loop is always here, and it's a very long process. Sometimes it lasts months. For that reason, I wanted to present like a use case. This is an extract of my master thesis, so it's a very recent work, because now I'm a PhD, but I was like a master student a few months ago. And the case is basically an exploratory tool for domain expert, and data are coming from Twitter and Reddit and online news. And these data have been categorized with algorithm of topic models. I don't know if you all know what is an algorithm of topic modeling, but basically I want to, give an idea. I'm apologizing with all the computer scientists. Maybe I will be very, very superficial, so sorry. But basically, topic model algorithms read a collection of documents and try to see which are the topics this document talk about. So basically, from a collection of documents, there's a keyword identification, and the keywords are like, these algorithms try to identify to what topics these keywords may belong. So in the end, we will have like a list of topics, possible topics, with a list of keywords. So this is basically the idea. And the topic that we work on the issue was the opioid epidemics in USA, and because, the drug overdoses are one of the leading causes of death in America. And our goal was basically to represent text, because when you are working on documents, one of the goals is to represent text, and visually represent text is very, very hard. For that reason, in this process of choice of visual models, because which were the most appropriate visual models for visualizing these documents, this text. We tried to define like some parameters that described our data. Our data were about time, because our topics were a long time, and our data talked about the relation, because we wanted to show which were the similar topics that had in common some keywords. And starting from these two parameters, we create these metrics. In this matrix, we list a series of visual models, maybe appropriate visual models, and here we put time and relation. And we started to test with users. The first visualization that we made was a tag cloud. A tag cloud is basically a group of keywords, and the size of each keyword is related to the relevance of that keyword. And it's clear that here appears that some keywords are more important than others, but the user said that the readability was very low, and it was very hard to detect topic. And very, very important, there was no time variable. So in our path between data and information, between data and knowledge, we were kind of here in the middle, still in the loop. It didn't work. Then we tried with the circle packing. The circle packing is a common visualization if you want to represent a group of objects, and each circle, each black circle is basically a topic, and inside we have the different keywords. And here is represented a day of tweets. But actually it's very, very, very hard to see the keywords. You can't read the label. It's quite impossible to detect topics. And also in this case, there was no time. So we said, okay, let's go deeper. Let's think about, okay, we can keep only 1 hour, not the whole day. And this is the representation of 1 hour of tweets with 5 topics. And we discovered that if we zoom in just a little bit, the readability was better. But the problem was that we had only a small time interval. Okay, so it didn't work as well. So we try with the networks. I think that you all know how a network works. This is a normal network. We have all the keywords, and these keywords are connected by the topic they belong to. So it's very easy to see that, for example, in this area, we have the keywords that are shared by many topics. And then in the periphery, as Gianna said yesterday, we have like some very peculiar topics, characterized by their own keywords. And looking at this network, we can also see, like, for example, that there are some big cluster, and we can also organize the network like in 3 parts, because on the left we see the keywords that talk about the use of opioids, the abuse, then the addiction, then the rehab. So the network seems to work, and the readability was good according to the users. It was easy to define cluster, but even in this time there was no time. So we decided to shift and to try something that was related to time. This is the stream graph, and the stream graph is basically a representation of time, is a time-based visualization, and each flow is a topic, and the size of each flow is the importance of each topic. And we discovered that isolating each flows was readable, the way a topic evolved, but was very impossible to see all the keywords related to each timestamp, to each time interval. So for that reason, the user said the readability was good, there was a clear highlight of the topics, but there were few keywords, even if there was time this time. We tried the same with a bump chart. This is basically a very similar visual model. And also in this case was like the same. And the user said that the keywords are always not a lot, so it was not really important, really interesting. So we fill our metrics, and starting from these metrics, we create a plot, a scatter plot with readability and content. So how much can I read from this visualization, and how much can I understand about the content of data? And we plot our visual models, And we divide our space in 4, and we decide to pick this area, so the most readable area and the area with the content that was more appropriated for creating our visualization. And this is a method that we usually use for creating a combination of visualization, because actually our goal was to design an interactive tool for domain expert for monitoring behaviors on online conversation. And so we had to combine this visualization, because sometimes if you work on static visualization, you say something, okay, it's working, but it doesn't really work for my purpose, for for the users' needs. So what we did was basically to create an interactive visualization, and this is called TopTom. This is the name of our tool, and this is a stream graph. So this is the first visualization that you can see, and the users can interact with this stream graph, can hover and see only a keyword for that moment for each flow, and the user can see how the topics are combined, so which are the different relation to the topic, can click on a single stream and see the keywords, 4 keywords per each hour, and clicking on the timeline, the user can also see the topic that characterized that hour, and go in this visualization is kind of a combination of network, circle packing, and tag cloud. And this is very interesting because the user could also click on the visualization and see the document. So this is, for example, news related to that document. And so this was our result. And basically, what I want to say is that when we do visualization, when we try to visualize, it's very important that we keep in mind that, yes, we are approaching an exploratory design era, so we need to think about the users, but what is really important is to use, test, and fail, because failures are important. Failures are important, and we need failures to do visualization. I think that I was really faster than what I thought, but I thank you, and if you have questions, thank you.